Hello everyone. So in the previous class we have studied about context free grammars and we have seen what is the definition of a context free grammar. What is derivation? It is a process of deriving a string of terminals from the given set of production rules in the grammar. Then we have seen two types of derivation. One is called as the leftmost derivation, where we replace only the leftmost variable every time when we derive, and the second type is the rightmost derivation. And then we have also seen how to write a parse tree for the derivation that we have done. So the parse tree is also called as the derivation tree, and what we get from the parse tree is called as the yield of the tree. So once we know all these concepts, we will continue with the problems. So in the problem here they have said, consider the grammar and perform the rightmost and the leftmost derivation to obtain the string. The first string is w is equal to AAA followed by a small b. Then the second string is 2 a's followed by a single b. And the given set of grammar production rules are these three. So we have to consider this and try to derive these two strings. Each time we have to perform two types of derivation. So first is the rightmost derivation to obtain the same string, and the leftmost derivation to obtain the same string. So let us first consider the first string, which is nothing but AAA followed by a B. So first we will perform the leftmost derivation. So in the start symbol, there are two productions. So we have to make a choice which one to use. So therefore, since we have 2 a's here already and we have this 2 a's here, we can choose S goes to A and B. Now in case if we do this, what happens? So you can see that there are 2 a's and what can be substituted for B is just a single B. Okay? So it is not possible for us to derive this string. Therefore, the choice of the production is not AAB, but rather it is AB. So here we have to choose AB. So that is how we are going to decide upon which one to use whenever we have some options. So A and B. And whenever we are doing the derivation, we have to mention whether it is a leftmost derivation or a rightmost derivation by writing LM or RM. And this is by the production S goes to AB. So this is the production rule that we have used. Next is, we know that this is the leftmost variable. So A has to be replaced, and we should also look into whether we need a A here or a B here. So the first symbol is a small a. So therefore the choice is a single A or else more A's. So we see that we need more A's here and not just single A. So this is not the choice, but this is the choice. So we use the production A goes to A. So therefore it is A B. So next, this is the leftmost variable and we need more A's. So therefore the production that we are going to use is nothing but A goes to AA, which is recursively generating more number of A's. So therefore again this A will be replaced by AA. These two will be written as it is. Okay. So next we do the leftmost. So this is the leftmost variable that we are going to alter. So here 2 A's are already there. So here we need just a single A. So therefore this A is going to be replaced with this production. The production rule that we are going to use is A goes to A. So we write here A goes to A. The rest of the things will be written as it is. Next, after 3 A's, we require a single B. So therefore this B has to be replaced with this production. So here B goes to small b. So therefore you write here 3 A's followed by a B. So we will stop the derivation here because we have arrived at the string that we required. Okay. So we can write a parse tree for this. So the parse tree is going to be First we started with a S, therefore we write S. S is replaced with two branches. So that is A and B. So every character is one branch. Next, this A was replaced with capital A, small a. So this A will be replaced with capital A, small a. Next, this A was replaced with a small a. So this was replaced with a small a, right? Rather, this A was again replaced with A, and this A was replaced with a small a. So we have finished this step. So A So once we have finished the derivation, we can write the parse tree for the derivation. So the parse tree first starts with the start symbol, that is S. Then we have two branches here because S is replaced with AB. So S is replaced with AB. So it has two different branches. This A is represented as AA. So this A again will have two branches for A, capital A, small a, then the capital B will remain as it is. Next, this A is again replaced with capital A, small a. So this A is again replaced with capital A and small a. So once we have done this, next this A is replaced with a small a. So this A is replaced with a small a. Next, capital B is replaced with a small b. So this capital B is replaced with a small b. So this is nothing but the parse tree that we write for the derivation. So once we have written this, the yield of the tree is nothing but from left to right all the terminals. So from left to right all the terminals when we see, so these are the terminals and we have to read them from left to right. So first leftmost A, then this A, then this A, then B. So from left to right. So this is the string that we have got from the tree. So the next step is to do the rightmost derivation for obtaining the same string AA, AB. So far we have done the leftmost. Next we will do the rightmost derivation. So second derivation for the same string, So I am going to write this as B and we will take this as A. So B will be RMD. So when I write RMD, so it is rightmost derivation. So this was the leftmost derivation. So in the rightmost derivation, we will start deriving. So S goes to AB. We chose S goes to AB because AAB cannot generate the third A. Okay, so therefore S goes to AB. Now, which is the leftmost variable? B is which is the rightmost variable? B is the rightmost variable. From the right side, this is the first variable. So this has to be replaced. So we are going to use the production. Here S goes to AB, production is used, and here B goes to small b, production will be used. So A and small b. Next, this is the rightmost variable. So we will have to replace that. So Rm. So this is the rightmost variable, and in place of that we need 3 A's. Okay. So A goes to A and capital A, small a is there. So this is the one which is generating more number of A's. So therefore we will choose that production. So here we will write A goes to AA. So once we do this, we will be able to generate A's. So next we will write here AAB. So now we know that we need 2 more A's. So therefore we have to generate it by using the same production. A goes to AA. So this A will be replaced with AA. AB will be written as it is. Okay. So next we are going to use the production. 3 A's are there, 2 A's are already there. So, here in place of this A we need a single A. So, therefore, the production that will give us single A is this production. So, A goes to small a. So, A goes to small a. So, this is the rule that we are going to use and we are deriving it. So, Rm small a, the rest of the things will be written as it is. So, we will stop the derivation here because we have arrived at the terminal string. So, the same step is repeated once again. We have to draw the parse tree. So, first S is taken up, it is replaced with 2 symbols, therefore, 2 branches A and B. Next, this B is replaced with a small b. So, this B is replaced with a small b. This A is replaced with capital A, small a. This A is replaced with capital A, small a. Then this A is replaced with capital A, small a. This A is again replaced with capital A, small a. This A is replaced with a small a. So, this A is replaced with a small a. So, this is the parse tree for the rightmost derivation. So, when we have the rightmost derivation also, if you check all the symbols from left to right, it is 3 A's followed by a B. So, that was what was asked to derive, 3 A's followed by a B. So, this is how we choose the productions in different order in order to generate a string. So, we will concentrate now on W is equal to AAB. So, now we are going to concentrate on the second part of the question where W is equal to AAB is the string that we are going to derive. So, we will perform the leftmost derivation, the rules of the grammar will remain the same. So, first we may use the leftmost derivation. So, we write LM, and when you see the string here and look at the productions here, so AB is one choice and the second choice is writing AAB. So, we see that this will be served if we use the production AAB. The purpose of deriving the string will be served with AAB because we know this 2 A's are already generated and in place of this B we need a small b. So, this could be a better choice. Okay. So, this is the production S goes to AAB. So, observe that I am going to write a double arrow mark when I do the derivation and write a single arrow mark when I am representing the production rule of the grammar. So, next step is going to be, we know that this B has to be replaced with a small b. So, therefore, the production rule is going to be capital B goes to small b. So, this production capital B goes to small b. So, we have AAB. So, this is the end of the derivation because we have arrived at the string which was required. We will write the parse tree for this. S goes to, it is replaced with 3 symbols. So, therefore, we will have 3 different branches. So, the first branch is small a, second branch is also small a and the third branch is capital B. Next, capital B is getting replaced by small b. So, capital B is getting replaced by small b. So, no more steps in the derivation, and this is the parse tree that we write. So, what is the yield of the parse tree? From left to right, read all the terminals. A, small b, small a, and small b. So, this is the yield of the tree. Next step is performing the rightmost derivation for the string AAB. So, S goes to, we write RM here, and here also we write LM. So, RM, so we will take the production AAB. So, we know that we are using the production S goes to AAB. Okay. So, this itself is the rightmost variable. So, therefore, we will replace that with A small b, because we have the production B goes to small b. So, therefore, this is the end of the derivation. So, we will write the parse tree. S goes to 3 branches for 3 symbols A, capital B. This B goes to small b. So, this is the parse tree and the derivations, both the leftmost derivation and the rightmost derivation for the given problem. We will move ahead to the next topic, that is learning to find out if the grammar is ambiguous or not. The meaning of the word ambiguous is nothing but it is confusing. Okay. So, in case the grammar can produce the strings in two different types and produce two different parse trees for the derivation of same string, then that grammar is called as ambiguous. So, if you perform the derivations and if you find that the structure of the parse tree differs, then you call that grammar as a ambiguous grammar. So, the next question that arises is how to find out whether the grammar is ambiguous, whether to apply two leftmost derivation or whether to apply two rightmost derivation or one leftmost or one rightmost derivation to compare the trees. So, all these three cases are possible. Okay. So, therefore, in order to produce two trees to compare, you can use two leftmost derivation or two rightmost derivations, or one of them can be a leftmost derivation and the second derivation can be a rightmost derivation. So, produce two different parse trees and compare them to see if the structure is same or different. If the structure is same, then we call that as unambiguous grammar, and if the structure is different, then it is ambiguous grammar. So, let us look at an example and check whether it is ambiguous or not. So, we will consider the problem, consider the grammar and check if it is an ambiguous grammar for w is equal to id plus id star id. So, this is the string that we are going to generate. So, id is the terminal, plus is a terminal and star is a terminal. So, therefore, this is what we are trying to derive from the given grammar. So, first we will do the derivation. So, I am choosing to do one rightmost derivation and one leftmost derivation. So, we will do the derivations first. So, E, we will concentrate on w is equal to id plus id star id, right. So, therefore, we will start with the derivation E leftmost derivation E plus E. Okay. So, this is a grammar which is going to generate expressions. So, that expression here what I require includes a plus sign. So, therefore, I can use E plus E. So, next E goes to E plus E. So, what is the leftmost variable? So, this is the leftmost variable. So, this has to be replaced. So, before this plus I have a id here. So, therefore, in order to generate an id, E first has to be replaced with capital I. So, therefore, the rule that we are going to use is E goes to I. So, first we write I here and then we write E. So, this is the leftmost variable and we require id in place of I. So, therefore, the production rule that we are going to use is I goes to id. So, this I will be having id plus E. So, next this becomes the leftmost variable. So, this leftmost variable again has to generate something. So, what is there after plus? So, after plus we have id star id. So, therefore, E should be able to generate E star E. So, therefore, id plus this E is getting replaced by E star E. So, write E star E. Next, this is the leftmost variable and in place of this we need a id. So, therefore, E goes to I, which is for an identifier. So, id plus I star E. So, this is the leftmost variable. I goes to id. So, therefore, we will write here id plus id star E. Again E goes to capital I. So, id plus id star I. Next is I goes to id, therefore E goes to id plus id star id. So, this is a string that we required and therefore, we have done the derivation. So, let us try to write the parse tree for this derivation. Okay. So, when we write the parse tree, we will write the parse tree here. So, E is going to E plus E. Next, this E is replaced with a I. Next, I is replaced with id. Next, we have this E which is getting replaced with E star E. Then, this one is getting replaced with I. So, this E is getting replaced with I, then I is getting replaced with id. Next, we are replacing this E, that is the rightmost E. So, this E is getting replaced with I, from I it is getting replaced with id. So, this E is replaced with single symbol I. So, therefore, single branch I, then this I is replaced with id. So, this is the tree that we have generated for the leftmost derivation. So, let us make another derivation. So, we will now concentrate on the rightmost derivation. So, rightmost derivation. So, we will start with E star E. So, the production rule that we are going to use is E goes to E star E. Next, E in the rightmost derivation. So, this is the rightmost variable. So, you see here after star what is required? Only id is required. So, therefore, we will first use the production. We need an identifier. So, E goes to I. So, this is E star I. Then, this is the rightmost variable I. So, therefore, I is replaced with I goes to id. So, therefore, we will write id here and write star E. Okay. So, next step. So, this is the rightmost variable. So, before this star what is there? Before star we require id plus id. So, therefore, E when we do the rightmost derivation. So, this E has to generate E plus E. So, therefore, E is replaced with E plus E star id. Next, this is the rightmost variable and in place of E we are expecting a id. So, therefore, first E has to be replaced with I. So, it will become E plus I star id. Next, I is getting replaced with id because this I is the rightmost variable and in place of this I require id. So, we will use the production rule in the grammar I goes to id. So, E goes to E plus id star id. Next, we look at the string here. So, before this plus what we require? So, before this plus we require a id. So, therefore, again this E is replaced with I is replaced with id. So, we know these two rules from the steps that we have already done. So, this is I, this goes to again id plus id star id. So, this is what we have done. So, we will write the tree for this now. So, E is first replaced with E star E, 3 symbols. So, 3 branches are there. Next, this E is getting replaced with I and this I is getting replaced with id. So, this has become I and this has become id. Okay. Next, what happens here? This E is getting replaced with E plus E. So, this E is getting replaced with E plus E. Okay. Then this has got replaced with I, because this is the rightmost, and then with ID. Then this becomes the rightmost. This has got replaced with the I, and then it has got replaced with the ID. So, when we look at the two trees here, one for the leftmost derivation and the second for the rightmost derivation. So, we see that the structure of the C tree is different. So, see here, the leftmost E, we have this branch, whereas we have two different branches for the leftmost E. So, the structure of this tree and the structure of this tree are different. So, therefore, we will conclude that the given grammar is ambiguous. The given grammar is ambiguous. Okay. So, in case if I take an example also and check if the grammar is actually producing two different results for the same kind of derivation of the same expression. So, let us take up ID is equal to 3. Let us take up ID is equal to 3. So, what happens here? So, in the tree always the evaluation of a parser will take place from the bottom of the tree to the top of the tree. So, the very first thing that is done here is ID star ID, which is the bottommost part of the tree. So, first we will evaluate 3 star 3. So, 3 star 3 is nothing but 9. Okay. Next we will come to the next level. Okay. So, ID plus 9. Okay. ID plus 9. So, that is nothing but 3 plus 9. So, 3 plus 9. So, it is going to give us the result as 12. Okay. So, here we will do the same evaluation and we will see if it is producing some other result or it is producing the same result. So, this is the bottommost part is this evaluation ID and the evaluation is ID plus ID. So, ID plus ID will give us 3 plus 3, which is 6. Okay. Next evaluation is 6 star 3. Okay. So, 6 star 3. So, this evaluation has come here. So, this end will have a 6. Okay. So, 6 star 3. So, this is going to give us the result as 18, while we see that the expression is the same. The expression is ID plus ID star ID. So, in whichever case it has to produce the same result, but it is not the case in this grammar rule. Okay. So, here one type of derivation is giving us the result as 12, another type of derivation is giving us the result 18. So, the computer will not be able to give us a proper result when the rules are ambiguous. Okay. So, this is happening here because the precedence of the operator is never considered. Okay. So, this type of grammars which will yield two different structures for the trees are called as ambiguous grammars. we will consider the second problem and find out if the grammar is ambiguous or not. Again, we are aiming at producing two different parse trees. Okay. So, the given grammar is S goes to AS or X, X goes to AX or A. So, X is recursively producing one A or more A's, okay, and the grammar is making sure that at least there is one A in the grammar. So, the string given is 4 A's. So, let us do the derivation first. So, S in the leftmost derivation, so S goes to AS, okay. Then we can say S goes to X. So, this is S goes to X. This is S goes to AS. Next, this X can be replaced with AX. So, AX. Next, this is the leftmost variable. So, X goes to AX. Next, in place of this leftmost X, we require a. So, therefore, we have the production X goes to small a. So, therefore, we write that production and produce the string trip 4 A's. Okay. Next, we can do the same derivation second time and we will see if we can produce the string. So, leftmost and rightmost both the variables are X. So, X is supposed to produce more number of A's. So, we will use the production X goes to AX. So, here we are producing the third A. So, we are concluding the derivation by this X when it is replaced to a A. So, we will write the tree for both the grammars and check if they are different or same. So, we will write the tree for the first derivation. Here S goes to AS. So, S will have two branches, one is A and one is for S. This S is replaced with a X. So, this S will be replaced with a X. Here this X is replaced with AX, X is getting replaced with AX. So, this X is getting replaced with a AX. Again this X is getting replaced with a AX. So, again A and X. X is getting replaced with A. So, X is getting replaced with A. So, this is the first parse tree that we have done. Okay. So, we will write the second parse tree. So, S is replaced with X. Okay. So, the very first production that we have used is S goes to X. Okay. Next, we have replaced X with AX. So, this X is getting replaced with AX. Then again X is getting replaced with AX. Two branches, one for A and one for X. And again X is getting replaced with AX. So, this is again A and X. X is getting replaced with A. So, this X is getting replaced with A. So, if you look at the structure of the trees here. So, first of all S, starting from the S which is the start symbol, there are two branches here, whereas it is just one branch. So, if you compare the structure of the tree, okay, so the structure of the tree itself is different. Okay. So, we draw the conclusion here, the given grammar is ambiguous. The given grammar is ambiguous. So, also note here we have done two different derivations. The first derivation is the leftmost derivation and the second derivation is also a leftmost derivation. So, it is possible for us to do 2 leftmost derivations to prove that a grammar is ambiguous. In the previous example, we have done 1 leftmost derivation and 1 rightmost derivation. So, that is also possible. Okay. So, this is how we conclude whether the given grammar is ambiguous or not. Thank you.